Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida.
So in this section we will deal with all things pertaining to artificial intelligence, otherwise known as AI.
So since the basic coding for GridWorld is complete, and there are some issues in regard to the specifics, how they want it run, I don't want to waste my time on that. I've got the elements understood and down. So I'm moving on to a new project which we're going to call Sensor World, in which we'll have a robot with sensors, and it won't see anything in the beginning. It will only detect things as it moves around, and that's the basic concept. So this is the world that it will see when it's been all the way around and detected everything. And what I'm going to do is I'm going to go through the code bit by bit as we go along, hopefully, and at the end the objective is to move up to a deep reinforcement learning algorithm that will include neural nets, which is another problem on itself. So we'll move over to the code base, and it's still a little bright in here for me, so let me just attenuate that a bit. So this is where we start. This is the rest of the code. I've blanked it all out, and we're going to start with what we're bringing in. So we're importing tkinter, which is the framework for the graphics. NumPy will be used and time may be used. It's now called Sensor World. I think it's supposed to use non-capitals here. Is it complaining about a non-capital? I don't know. Anyway, the init, we have defined the sensor world itself, which is just a green block, and we have blanked everything else out other than the table, so we can forget the table for the moment. Just take that out because that's all you're going to see when it runs. Famous last words, right? Famous last words, because I don't have this activated. So let's do this one at a time. We'll do this one at a time. So here we just have our basic grid, which we'll get rid of in a minute. Come back over here. So the frame, you can put any name you want in here, but this is the cardinal point for getting the window open. So it's a 500 by 400 window, and I've set it to green, and that's the code for that. And you have to pack it to make it observable. You don't have to pack in there, it won't run. So I'm just going through these for people who are not familiar with it. You just get your basic little window if you don't put pack in there. And if you're new to tkinter, put pack in there, run that, and you've got your table. So we'll get rid of that. And now we'll come onto the reward table. The reward table is the same as in GridWorld because we want to hold data that we'll need to put onto the grid, and the NumPy table will allow us to put those numbers onto the grid. So let's go through the NumPy table code. There is a variable s, which is 0. This is a NumPy array of 11, 0 through 10 as 11 units by 5 units. So we have, you can call this what you like, I'll just call it SR. So it's a NumPy array of zeros, x, y. The data type is object because we need to put two data types in there. We want a integer here and we want a float here, and we have to differentiate them. So the data type is object, so we can change it. We're going to run this through a range. The first element is left out, and the rest are set to floats. And so all these are now floats, and then we put x in as a variable, which is this number here, which is going to loop through, and we set this value to 0, and when it loops through, and that will actually give you that. So that's the code for giving you that, and we're going to save this. Now you have to do NumPy array save, so this is how you save it. You go NumPy save, put the root in to where it's going to be saved on your desktop, so to speak, and give it a name. Give it the code name. The code name is the name of what this thing is here. SR is the code name for this this table, and we need to save that because we're going to be bringing it up and we need to load and put stuff into it. So there's, we've printed that out. So we don't need that anymore, so we'll get rid of that. And we will get rid of the data water. I don't think it matters. So we're just going to upload the maze. So that will just need that out of there. So this is without anything on it. So what we're going to do now is we're going to fill that in with black. So we're going to create a rectangle. These are the specifications. We're going to fill it in with black. So we now got our black rectangle. And I've gotten rid of the other things, so never mind. Now we're going to put a white border around that rectangle. I think we're going to put a white border around that rectangle. So we're going to put a white border around that rectangle. Now this border is going to become thickened as the robot. This is not the walls. This is just the world it's in. This is the sensor world on the framework. So when the robot sees the walls, it will actually put the walls in. So we'll take a look at the robot. Now we're going to come onto the maze. At this point in time, we need to call the reward table. But when we actually run it later on, we'll call the reward table in the move element, and then the maze itself. But I just had to put that in here for now. So that gives us that framework. Now the sensor robot is going to be brought in separately because it's a number of elements. So first of all, we will bring in the robot. So you have to give the agent, we have to enable this. So this function is to define the graphics of the sensor robot. It has to be given a name, and it has to be given a framework of an oval, because that's what it is going to be, an oval. And when you just put the oval on, this is what was on Grid World. Thank you. We need to do something. Activate the sensor. Okay. So we're calling in the robot, and so in comes the robot. Well, this is its framework. Now that's what was on Grid World, just this little oval. But we're going to give the robot some little sensor points from which little green sensor, acoustic or visual sensors are going to come out, and the basic plan is that they will overshoot the wall. When they hit the wall, it will tell it that it knows there's a wall there, then we'll fill the wall in. Otherwise it will go through the line and detect the line into the next grid and enable that as a pathway to go down, and then thereafterwards it won't go in these other directions. We'll put that into the code, so it's sensing its pathway around the grid, sensibly so. So we're just going to fill these in one at a time. Let's plump them in, and variously we'll just put one in. Where are we? What does it not like? What are you getting so all upset about? Because that's out of line, right? Now what you do is you put these sensors in first, and then you put the agent on the top of them. Because if you do it the other way around, hello, thank you, then let's put you in. If you do it the other way around, then you find that your sensor is overlapping the agent. So that we're going to be calling this as a unit, and then thereafterwards, when I get to it, we'll do the sensor bit as a further add-on to when we say go, it's going to actually put out its sensors, detect the walls, then in the next section it'll build the walls, build that framework from its status go, and then it'll decide about on its movements. So we're going to put this back and fill the rest in. You just need, oh silly ass, you just need to learn how to fill in these various data points just by practice, really. So they're all rectangles filled with these specifications of their little distances. we put those in first, put the agent on top of it, and there we've got our agent. Now this is the start point. This is the world. It doesn't see anything. Remind you what the world looks like, so we can compare the two. We'll put those back over here. Bring this out. Oops, I got all these things on here. Where is it? Oh, it's there. And we need use. All right, we'll split these now. Well, let's do it the other way around because I want to be able to show and explain what's going on. So the agent starts off in a world it doesn't know any information about. This is ultimately going to be the world where the data is going to come in, it's going to get to here, reach its rewards, backfill, integrate them through the system. So that's the first start point of the code. We can get rid of that because it gets in the way. And I think we've been through all the code now. So let's just, and we have to activate the loop in here and basically enable the code to run. So data equals sensor world, data equals maze. If you're not familiar with this, you'll have to do some work to catch up. So we'll just go through this quickly once again. I've gone through it stepwise. So introduce tKint and NumPy we'll use, time we'll use, introduce the class in it for the framework. The reward table we'll be using later on, and we've saved that. We've built an agent for the moment, which is just this guy here. We've put this on here. We don't need that on there for the moment. It doesn't make any difference one way or the other. Just had it on there for building up things. When I was degrading degrading the one world into the other world, I needed to see what I was getting rid of. So we have our black framework, and we have our line around it, which is going to be a thick line, and we've called in the robot, and we've activated the loop. So that's the code for the first part of this, and I will put it up on GitHub, and everything I put in there separately I'll put it as the second version kind of thing. So below this I'll put up the GitHub reference so you can just go and get it, and that's going to be part 1.